hours. Write a function that models the height of the tide. This actually, it looks like a scary problem, but it gives you a lot of good information in there, doesn't it? What do we need to know to write a function? Give you the amplitude, period, and if there's any shifting, right? So amplitude, how can we find that? Good. The 3.9 minus the 3.3, which gives you the distance between the highest and lowest values. And divide that by 2. And so 0.6 divided by 2.3. So that's your amplitude. Any questions about that so far? Okay, let's talk about the period. It says the tide peaks every 11.6 hours. I think they just gave us the period. Agree? They said every 11.6 hours the tide peaks. So it's back to its peak after 11.6 hours. So the period, which is 2 pi over b, equals 11.6. Cross multiply. If you haven't noticed, you can just divide the 2 pi by the 11.6. You can either leave it as a decimal, or you could leave it as a 2 pi divided by 11.6. I would take both answers on this problem. And how much is that? Just out of curiosity. So either way, either way would work great. That should be that. Now let's try to figure out if there's shifting. Is there a vertical shift? First of all, how would we find the vertical shift? And how would you find that? Okay, it says because the tide is 3.6 meters at t equals 0. Maybe that's telling you it. Maybe. How do I really know for sure though that that's it? The average of the 3.9 and the 3.3, 3.6 is right in the middle. Now, let's talk about writing a function. It doesn't tell me I have to do sine or cosine specifically, so I get to choose. Which one would be easiest? Since I start at the middle.
Sine.
Sine. What do I mean I start at the middle? At 0, at time 0, I'm at the vertical shift, right? So I'm at that midline. So if I start at the middle, I would not have to do a horizontal shift at all. So sine function. So that's nice. It's 0.3 sine of 2 pi over 11.6 x of t, either way. And again, if you put the 5.54 together, that'd be great also. And then plus 3.6. So there was no horizontal shift, and that made it nice. Graph the function. I could do that by hand. I could do that in a calculator. Both will work. Do you have a question? For time that you could put in it, see what you're writing. And it's just some variable for but since it was time, I picked the t just for that reason. You can do it. There's always a variable there. Otherwise, you would just get the sign of a number, which would give you a horizontal line if you got it. Speaking of, have y'all ever accidentally done that yet?
What?
Tried to graph sine of x and accidentally put sine of 3? Or try to graph sine of 3x and just put sine of 3? If you do, it's going to give you a horizontal line because, well, not sine of 3, but a horizontal line because you're going to go find the sine of 3 radians, wherever that is. It's just going to give you that horizontal line. Does that make sense? So, if you ever accidentally do that and you get a horizontal line, you'll know why. You're just getting the answer to what sine of 3 is. It's decimal value. So there would be no, it would not be a changing function. Graph the function. You could probably do this from the words, right? You probably wouldn't even have to do it from the equation, but we could do it either way. I know that, let's see, moved it completely up off of the x-axis. I'm not showing my whole grid there. So I'm up at 3.6. I start there, and then I'm going to do 4 tick marks, right? In 4 tick marks, where do I end up? What time do I end up at? 11.6 hours, right? Now, I could go through and find what each tick mark means. I just divide that by 4. If I wanted to know what my tick marks are labeled by, I could. So I'm going to go from there. Determine the height at 6.2 hours. What would I do? Plug in 6.2 into that function, and what do I get if I plug in 6.2 into that function? Someone with a calculator in radian mode, do that for me. Make sure it's in radian mode. Too far down. Bottom point. I don't know if I did any better.
3.536.
Okay, and that unit would be in meters. Any questions about that? Okay, we're going to do another temperature problem, and just because of time, I'm actually going to skip and do question E first, and then we'll go back and do it by hand. If we need to, it's very similar. Do y'all remember the temperature problem we did? What city? Chicago. We did Chicago. This one is Seattle. So we're doing temperature in Seattle, Washington. I know that I can find this by hand. I would look at the very highest value, which it appears to be 66, and the very lowest value, which is 41, and I would use those 2 points to find the height and all of that fun stuff. Again, I can do that again, but I do want to skip down and show you how to use your calculator to do this. So if you will get your calculator out, you have used this feature in your calculator before with linear regression to find an equation of a line. So we're going to do this to find the equation of a sine function. In your calculator, push the Stat button, and then push Edit, which brings up your list. Go up to your L2. Be very careful when you do this and listen very closely. Go up to L2 and push the Clear button. Don't push Delete, push Clear. Go up to L1 and do the same thing. So clear those lists out. Do not delete the lists. They will go away completely, and we will have to reset up your editor, which we can do, but it's not too bad. Just don't. If you ever accidentally do that, stay here, don't move. But if you ever accidentally do that, go to Stat and go to Setup Editor and reset your editor up, and that's how you'll fix it. Anyway. So in L1, let's put the months. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. In L2, we're going to put the temperatures. I'm going to move my calculator for a minute. Y'all okay with that? So we can all see the temperatures, and I'll pull my calculator back up once we have the temperatures typed in L2. So for January, you'll put 41 and so forth. equation for me. Now there's a lot of things you can do from here with your stat editor. Just a couple of things, don't do any of these because that's not what we're trying to do today, but you can, again, you stay where you're at, but you can go to second y equals and turn your plot on. You can get your calculator to plot the points for you. You can do a lot of different things in your stat. If you ever accidentally have points on your graph and you wonder where they came from, your stat plot is probably turned on. So you go turn it off, it'll fix those random dots on your calculator. So I could do that again. You don't have to do any of this. I could turn that plot on and zoom data or something like that. Zoom stat. And it will show me the graph of this. So you can kind of see I have something in my y equals, that's why a random line came up through there. You can see this looks kind of like a trig function, and that's what we want to find. Now here's your part. Go to your home screen and go to Stat and over to Calculate. So this is the part you need to remember, so you might want to write that down. Stat Edit, type in the list, and then Stat Calculate. We're going to go choose the appropriate regression. I do want to let you know what all is available. You see the lint-reg, that's what you used last year, linear regression when you did. And you might have even done a quadratic regression. Did y'all do any? So you might have done a quadratic regression. You can see all of that there. There's cubic, quartic. There's another linear regression where they do the slope second for whatever reason. There's natural log regression. There's exponential regression. There's power regression. There's logistic regression. And then there's a sine reg. And so that's what we're going to choose. Does anyone's calculator not look like mine at this point? Like not bring up a menu. A couple of things, either I can give you my operating system in a little while and I can give you the menu, or I can show you how to do it without the menu. It's up to you. So for now, follow along with theirs, and then I'll have you come up and I'll show you yours specifically. Or I can just give you the operating system and you can have mine. Iterations, there was only one period in this, and that's what it's asking for, is how many periods were there. X and Y list, L1 and L2, as long as you did your work correctly, that would, or in L1 and L2, you could leave it. You could change those. If you ever do need to change those, you go to second 1 and second 2, or second 2 and second 3 if you wanted to use a different list. You can type the period in, but I'm not going to. I'm just going to push calculate. I'm going to have my calculator do the work for me. If you did know the period, you could type it in. So we get an A value, a B value, a C value, and a D value, and notice where they all go. So everyone see all of that information. What I do want to point out is when you write this equation down, they don't factor it out. Do you see what I mean by that? So don't factor it out. Don't write it down wrong. You're going to write it down just like that. You're going to round to 3 decimal places in each spot, and you're just going to write down those numbers. Don't write it as factored out unless you actually do the math to do that. Yes?
Why do you compare singular matrix?
Let me see your data. The only ones that do that singular matrix things occasionally is the trig regressions. It's that 4 right there. Threw it off. Didn't know what to do with it. You're welcome. Okay, any questions so far? I'm going to move my calculator, but I am going to write that answer down so you see how to write it. Y equals 11.921 sine of 0.537 x minus 2.323 plus 53.03. That's what we got. Now, if yours is a slightly different, but not a lot different. We may have just a different calculator operating system. They may be running the sign regression slightly different. If it's way off, what I do is go check your data, make sure you didn't type a number wrong. I would say that's probably what happened. Like Eric's had a 4 instead of a 40 something, and that happens. We all do that. So I would just check that data, make sure you didn't type a number in. Everyone else has got the exact same equation. Right. Tiny. It's just a tiny amount of different. We'll call it good. They actually made this more complicated when they threw in the iterations of the period. You used to not have the option to type those in, and now because you can type those in, it makes the calculator functions a little trickier. How does that compare? Okay, so let's go do this by hand, but I want to see another one by hand. Okay, so let's go do this by hand. So this will walk you through again by hand finding the function. The amplitude, how am I going to find the amplitude? 66 minus 41 divided by 2. 5, so 12.5. They got 11. Does that make sense? Does that seem reasonable? Ours is going to be different because we're not taking in quite the level of statistics that your calculator just took in. So I'm just doing top and bottom. They took into account all the points and average some things. So pretty close though. Vertical shift, 41 plus 66 divided by 2, the average. Divided by 2, so 53.5. What was this equation? Pretty good, right? So it looks like we're about right on the average temperature there. Find the period, 12 months, right? And so I am going to side note and go find B. B would be 2 pi divided by 12, or pi over 6. Okay, what was their number down there? 0.537. What is pi over 6?
24.
So they have
0.523.
0.523, and they had 0.537, so pretty close, and they didn't know it was 12 months. We didn't tell them the period. That's pretty good that just the points seem to fit that model. Write a sinusoidal functions to model this information. The big thing that we do have missing is the horizontal shift. Just for comparison's sake, I am going to work this by hand and find that value there with a sine function. You also could use a cosine function and shift it over 1, a negative cosine function and shift it over 1. That's easier. I would probably do it that way. Does everyone know what I mean by that? I would do negative cosine and then do x minus 1. Because a cosine function shifted to where the February or January is the minimum value, with a negative cosine function fit that perfectly, and I wouldn't have to. Does that make sense? I wouldn't have to think as hard. I'm going to show you the long way for if you can't think that through, just a more generic way to find it on any function. And that's by solving for that C value, or D, whatever your book calls it. So move down to part B. So I'm going to fill in every part that I know. I know the amplitude is 12.5. I know the period is pi over 6, or no, sorry, the B is pi over 6. I don't know C. And I know the shift is 53, what was it? Wait. That was 0.5. Thank you. Any questions so far? Plug in a value for x and y. because you're going to shift the minimum or maximum over. And so if I did January, I'll go to January, then X would be 1, Y would be 41. Solving. Subtract the 53.5 over, and I get 12.5, negative 12.5. See what I mean by the numbers working nice? Because you picked a minimum or maximum, it's going to be half that amplitude. Or the amplitude is going to be that value. Divide by the 12.5. And how do you get rid of the sign? Oh, sorry. I did not know why that 53.5 is still there. Oh, just you do that one. Okay, how do you get rid of the sign? Inverse. Inverse sign. Sine inverse of -1 is going to give you negative pi over 2 in your calculator. Y'all all know why your calculator is giving you pi over 2 for that, right? Makes sense. Multiply by 6 over pi on both sides. And I get -3. So -4 is negative c. C is 4. So, 2 options for answers on this problem. Sine pi over 6 is x minus 4 plus 53.5. Is that correct? So that's one option. The other option that I think is also great now, this is where it gets a little tricky as a grader, and don't worry, I will be doing grading on your test, so it'll work okay. Are these the only 2 correct answers? Now, if you picked a different value, your shift would, you could shift this as far over as you wanted to. So that phase shift could change. The things that aren't going to change are going to be the amplitude, vertical shift, and the period. Other than that, there's a wide range of answers in here that would be acceptable. Those are probably going to be the 2 most common. Questions about that one? And then it asks me to compare those 2. I would say there's a lot of similarities there. Would you? A lot of similarities. They're not exact, but I did a lot less statistics than I did. I just picked the top bottom. Okay. At a particular point in the ocean, the vertical change in the water, the wave action is given by this function where y is in meters and t is in time, in seconds. Find the amplitude, period, frequency, and phase shift. So this is a little different question. It gives us the equation, so I like these a lot better. You will like these a lot better if you do the equation. Have y'all started on that bookwork at all? A lot of them give you the equation, so that's nice. Find the amplitude, the period, the frequency, the phase shift, and graph the equation. So let's start with the amplitude. What is the amplitude? 5. What is the period? Okay. 2 pi divided by 5 or 6. We've done enough of those. Y'all probably know that. 12. That's 12. So that period is 12. So this is probably a month type thing. The frequency. So the period is 12. cycle, right? So with the time it takes 12 months to complete a cycle. What is the frequency? We learned that yesterday. Good. Now I'm going to cheat. Isn't it just a reciprocal?
No.
So 1/12. Frequency is 1/12. The units on that, so the first one was time to complete a cycle. Cycles over time. Cycles in a certain amount of time. So one cycle in 12 months, which makes sense. We're saying the same thing, just the reciprocal. So that's what a frequency is. And the phase shift is left 3 units. So maybe 3 months or something like that. And then graph the equation. It's no vertical shift, just shows me graphing nice. I don't have to move up and down. And my period is 12. So remember, the tick mark is the period, it's not the mean value, it's the period. So this would be 6 and this would be 3. So I'm counting by 3s on my which is 5. Sine quotient. Didn't tell me how much to graph, so one period good. It did tell me how much to pay attention. Graph more if I need to. Oh, sorry. You need to do this one. So I'm going to pick it up and move it left 3, which is 1 tick mark. Thank you. Is everyone okay with how I know it's 1 tick mark? So the flow graph is in it. The frequency is the reciprocal of the period. The period is 12, frequency is 12. Always the reciprocal of the period. I already gave you the homework if you feel like you got it and you want to start working. And I think I'll do one homework and it won't be that. If you want to work, you can. That's your homework. Yes, we do something.
negative cosine.
Negative cosine. So I'm just going to use that to save myself the time. Could you use the sine function and find a phase shift?
Yes.
Yes, I would rather not if I could avoid it. If I have to, I will. I showed you a couple where I did. So that's negative 16 cosine of pi over 3 times x. So you factor it out. No vertical shift. Determine the position at 1.5 seconds. Plug in 1.5 for x. And what do you get? Someone with a calculator is raising the.
You.
Do that. You bought.
Zero.
So I could maybe answer that by saying at the equilibrium position. Does that make sense? Yes. A fourth of 6, right? If you divided 6 by 4, you get 1.5. So it makes sense that you'd be hitting that equilibrium position. Find the frequency. If the period is 6 seconds, then the frequency is 1/6. And just for fun, what would the units be on that?
Oscillation per 6 seconds.
Good. Oscillations per second. So there's one oscillation, 6 seconds. Oscillations per second. Any questions about that? Do we go pretty good about
Definitely part of your reps. I need to walk students.
work on homework, ask
Even
questions. In
me.
5 minutes we'll break.